Now the next question, question 15, requires oxidation numbers. And before we do it, this video is actually just going to help. I'm just going to give you some of my own personal tips on how to solve these kind of reactions, because they can be confusing sometimes. But if you actually know what to do and you have specific rules and you remember the game plans, they can actually be very fun. Actually, I actually enjoy doing these. But you need to know how to solve them. So I'm just going to give you a few rules and just some examples on how to solve for these before we do question 15. So first of all, guys, when it comes to redox, if you remember, redox kind of is a combination of just meaning reduction and oxidation. And you most likely have remembered some things like Leo the Lion says grr and oil rig from what I hear. However, it's just important to also remember that while those are great, those little cliches and those little sayings are great, and I do believe in them, I think they're awesome, it's also just good to get an idea of what they mean. So what they mean by that is that for reduction is you are gaining electrons. And by the way, E- is just a chemical form of just saying electrons. And therefore, if you're gaining electrons, the charge of the atom or molecule becomes more negative. So in this case, another thing I'm just going to write down, just for a lot of people to remember, is that when you gain electrons, you are becoming negative. And why I say that, guys, is because of the fact that in common sense, it would think like if I'm gaining electrons, then I'm gonna raise. I'm gonna raise in value, and that's not the case here, guys. Because if you remember, electrons have a negative charge. So when you're gaining electrons, you're actually becoming more negative, and therefore you're actually decreasing in value or in charge value. And so that's one thing that trips a lot of students up, is that they forget that. And same with oxidation. So I'm actually going to write this in a different color now with oxidation. So in oxidation, guys, it's the exact opposite. In oxidation, you are losing electrons. And therefore, the charge of the atom or molecule becomes more positive. And also, when you lose electrons, you are becoming positive. And what I mean by that, I should also write this down, is that what I mean by becoming negative, you are decreasing in charge value. And you are increasing, when you're becoming more positive, you're increasing in charge value. So these are very important for you to remember, guys, because just to conceptually visualize what's going on. Because redox is going to be very important, especially in chemistry too, when you get into electrochemistry. So also, when it comes to this, let's now look at some of the rules of how you do redox. So now let's do some rules on oxidation numbers. So when it comes to oxidation number, guys, oxidation numbers are what I talked about with the charge numbers. I apologize for that. When I said charge numbers, I really meant oxidation numbers. So one thing about oxidation number, guys, is that the oxidation numbers The oxidation number are those little exponents you see sometimes. So if I see, like, for instance, Cl minus, this is the oxidation number, which is just a -1 charge, etc. You most likely remember this in class, so I'm not going to spend much time on that. But here's some of the rules, just for you to remember. Atoms or elements in their elemental form, like gases, so elemental forms have a Ox number of 0. So that would be like examples. Examples I'll give you would be like N2 gas, O2 gas, F2 gas, etc. A lot of your gases. Number 3 is the fact that when it comes to monatomic ions, the charge is always located in the top, like I told you, which is kind of up here. I'm not going to discuss that, like I said. But number 3 is that that groups 1A and 2A have a +1 and +2 oxidation number respectively. So 1A, that's like your Na, Li, the group 1 in metals, they're all gonna have a +1 charge always. It's just always the case. And group 2A, that's like your calcium, things like calcium and barium, like Ba and etc. They always have a +2 charge, guys, with their oxidation numbers. And so that's very helpful. They always will have this. I should also put down always. Number 4 is that with hydrogen, when bonded to, in most cases, hydrogen has a +1 charge. The only exception is when it's bonded to a metal, which is extremely rare. So H bonded to metal, it has a charge of -1. But usually, guys, this is very rare. I'll just put down rare. So this is usually what you want to just remember, that in general, hydrogen has a +1 charge. The same with oxygen, guys, is that, I'll put over here, is that with oxygen, has a -2 charge. The only exception is peroxide, which is O2 2-, and that has a -1 charge. But just like the fact of hydrogen, all the atoms with hydrogen, where it's very rare for it to be in peroxide form, so I'll just put down this as rare. Okay, and for the most part, these 5 rules are just your general rules. There are a few other ones which you can find in your textbook, and also you can talk to your professor about. But for the most case, these 5 rules are what you should know, and you should be good to go with redox, and especially with the following problems. So I guess I will see you soon in question 15.
The Teaching Center, UF's Learning Resource Center.